Hello and welcome to GrossiMath.com, where math is for everyone. Today we'll be solving question 4 from the 2018 Algebra 1 STAAR by hand. So let's get started. Okay, in this question it says the statement about a graph of this function. Okay, and the important thing to understand is that right away in the equation I see the letter x is an exponent, which means that this is an exponential function. Okay, and so now what am I going to do? Well, I'm going to look at these answer choices here, and I'm going to think about the exponential function and which one seems to fit. Well, the first thing I see is that it's talking about a point. So can we check a point? Sure, we can plug in an x and get out a y. Okay, the coordinates of the y-intercept. Well, the y-intercept, we can check that. The coordinates of the x-intercept, well, we can check that. And the equation of the asymptote, well, we can check that. Okay, so the first thing that I need to think about is, well, what does an exponential function actually look like? Well, an exponential function, draw that down a little, looks something like this, that if I was to draw an exponential function, it starts low and it goes high. Okay, or it could start high and come low if it's a decay. If this is a growth function, this is an exponential growth, there's also exponential decay. But in our example, we'll use this picture. Okay, so this point is called the y-intercept. And this point is called the x-intercept. Okay, the y-intercept is where it crosses the y. Let me just draw that a little bit over here instead. Y-intercept. Okay, so the y-intercept is where it crosses the y-axis. So this is the y-axis. And the x-intercept is where it crosses the x-axis. Okay. Now we have what they call an asymptote. An asymptote is basically works like this. If the graph, the graph basically gets lower and lower and lower, going to the left, it keeps getting lower and lower and lower. But there's actually a line that the graph gets closer and closer and closer, and it never actually touches that line. Okay, that is a totally separate line. It's not part of this green graph. That's why I drew it with purple. And that purple line is called the asymptote. The asymptote is a line that it gets close to, but it never actually touches. It just gets closer and closer and closer without touching it. Okay? If you like examples, like a brain example, we could say if the exponential graph represents a plane and the plane is taking off, the runway that it leaves behind is pretty much the asymptote. Okay? All right, so let's take a look here. Now, the most important thing to know about the asymptote is that it is a horizontal line for an exponential function. Okay, so a horizontal line follows our old rules of y equals. Okay, so horizontal, zero slope, y equals. Okay, so y equals means that it's a horizontal line, that the slope is automatically zero. That doesn't matter here. But this is the part that does matter here, that the equation should start with y equals. Well, why did I say that that matters? Well, look, this says the equation of the asymptote is x equals 6. Well, we cannot have a horizontal line that starts with x equals. This is a mathematical impossibility. So we cannot have that, and therefore we will eliminate choice D. Okay. Now what we're going to do is we're basically just going to plug in some points here and see what works. Finding the y-intercept is very simple. Can we plug in x equals 0 and see if the y-intercept would come out to be 6? Well, let's do that. I'll do it right here. Y equals, okay, 2 parentheses 0.7. The x would now be 0 plus 6. Now, here's something important. 0.7 to the 0 power. Basically, now this is a PEMDAS problem, right? Or in high school, we sometimes call it germ-DOS, so I'll write germ-DOS. Okay. Well, there are no groupings of any meaning. The exponent is there. Excuse me. The exponent is there. So I'm going to do y equals 2. 0.7 to the 0 power is 1. Anything to the 0 power is automatically 1. So that's how I got that so fast. I didn't just do a massive calculation in my head. 0.7 to the 0 power is 1. everything to the 0 power is 1 plus 6. And that means y equals, well, now I did my exponent. There are no square roots. Now I need to multiply. And then I need to add and subtract. Whoops. There we go. Then I need to add and subtract. Getting too close to the top there. Okay, so now that I've done that, I get y equals 8. Well, over here I was supposed to have y equals 6. So this choice is also out. Okay, so now, well, now I can do things by sort of brute force if I want. Okay. So another thing that you can do on the STAAR is to use a calculator to just Control N and put no. To just check a couple of points. Now, again, if you don't have a graphing calculator, even if you just have a scientific calculator, you can still do this problem by plugging in the numbers. And that's what I'm going to do in this problem. Okay, I'm just not going to do the arithmetic part, but I'm actually going to plug in these numbers here. Okay, so let's go to the calculator, and I'm literally going to take the expression here, the algebra part, 2 times 0.7 parentheses, and actually let me zoom that in so you can see it. Oh, whoops, I almost forgot to put the calculator on the screen. That's weird. Okay, sorry about that, guys. I forgot to put the calculator on your screen. It was on mine, but not yours. Okay, so let's start that over. It says which graph, blah, blah, blah. It says y equals 2 times 0.7 to the x plus 6. So this is the part that I need up here, the expression from my word problem. So here I'm going to put 2 parentheses, 0.7 parentheses. To put the x in the exponent, I just pressed a little up. And what I always tell students is put parentheses when you're going to put in a new number. We're going to substitute for x. Remember, we're not putting the x. The calculator will not give us an answer like that. What we're going to do is we're going to actually plug in, for example, -3. We're going to plug in that -3, and we're going to see if 0 comes out. So you can see right there that I am going to put right there -3. Now, why am I going to put -3? Let me show you here. That the answer choice here says x-intercept is -3 and 0. So -3 should make the number 0. So let's see if that happens. So right inside there, I'm going to put -3. And when I do that, I do not get 0. I get 11.83. Okay, so now we can really just make this a short thing. And what we could do, just to check the other point, is go up here and take that -3 and change it. Change it to -8. So that way we can check this point now too. And I get 40.69 blah blah blah, which is very, very close to this. So that seems to be effectively correct. This one was totally incorrect, so I think A is going to be the correct answer. Now this can be some kind of a problem, a rounding error or something like that. So let's see if perhaps there's, on the STAAR you might see it as 40.7 probably. Okay, but there's some kind of rounding error occurring there. Okay, so there we go. A, B, C, and D. And of course, we eliminated B, C, and D, and that's how we got our choice, which was A. Okay. All right, so that's how you can solve this problem by hand or using just a pretty much any scientific calculator can do the method that I just showed. You do not have to have a TI Inspire for that. You do have access to one on the STAAR, so that's why I'm comfortable using it in our by hand demonstration. Okay, so there we go. I plugged in some numbers and I used an elimination strategy to figure out that the graph includes this point. And there we go, or approximately that point. Okay, and there we go. So thanks very much for watching. I hope you learned something today. In this video, we reviewed exponential functions, the most important points on an exponential function, the definition of the word asymptote, and substituting values for x in a scientific calculator. Okay, don't forget to like and subscribe and to click the bell icon. And of course to visit the website where math is for everyone, www.grossimath.com. Thanks guys. Have a great day.